Welcome to lesson 67 of course 2. In this lesson we're going to learn some more geometric shapes and solids. We're going to identify them. We're going to describe polyhedrons by their faces, edges, and vertices. We're going to identify a three-dimensional figure from its flat pattern. Okay, let's get going. All right. So our vocabulary that you're going to learn in this lesson are: what's an edge? What's the face? We're going to learn geometric solids and polyhedron or polyhedra. We're going to learn what a prism is and what surface area is. I think most of you know what most of these are. We'll go into greater detail in the lesson. All right, so let's just start with the geometric shapes or the solids. They're shapes that take up space. Here's a few examples. We have a sphere, which is like a ball. A cylinder is like a can, a cone. Then you have your cubes, your triangular, and pyramid prisms. These are all prisms, right? And we also call those polyhedrons. Whenever they have no curved edges, they're all flat edges, then it's a polyhedron. If it's got a curve in it like these do, then it's not. All right? And then we also, when describing a polyhedron, because they have no curved edges, we deal with faces, edges, and vertices. A face is one of the flat surfaces. An edge is formed where two faces come together, and then the vertex, or the vertices, is formed where three or more edges meet. So it looks like this. So when we're looking at this here, and we've got height, width, and length, you've got this, all of this is a face. This right here is an edge, and this right here is a vertice. Okay, so is that too fast? I'm sorry. So this is a vertice. These are all edges. Every one of these is an edge, right? Every one of these is a vertice because there's three or more edges come together. And then all of these are faces. So this cube's going to have 6 faces, right? Okay. All right. So imagine if we were to take a flat rectangular object and shove it into clay, and then pull it out, what would we have? What shape would we have sitting there? What would it look like? Would it be 2-dimensional or would it be 3-dimensional? If it's in clay, it'd be pretty 3-dimensional, wouldn't it? And what would we call it? We'd call it a rectangular prism, right? So if we push it into the clay, all right, if we shove that into clay, it would look like this prism inside the clay. All right, so give me the names of a geometric solid to describe each of these objects. So what is a basketball? What's a geometric shape of a basketball? That's a sphere. A can of beans, that's a cylinder. And a shoebox, that's going to be a rectangular prism. Okay, so a cube. Think about a cube. A cube's a die. It's got equal sides. So how many faces does a cube have? How many edges does it have? And how many vertices does it have? All right. See if you can do it. See if you can get the answer. Go ahead. All right, now you got your answer. Let me show you what I would do. I'd go ahead and I'd draw one. I just draw 2 boxes, and then I just kind of connect the corners like this. That gives me my box. Okay, so I've got a cube. Now I know that I've got a cube that has 6 numbers on it, so I know that my faces are going to be 6. That's going to be this whole thing. That's a face, right? I know that. Now I count my edges. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12 edges. And my vertices, I can count those. 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. So you should have 6 faces, 12 edges, and 8 vertices. Very good. All right, moving along. Draw a cube and answer the following questions. So same thing. Let's go ahead and draw a cube. I'll draw it for you. Draw your own too. You just can't do it on the screen. Do it on a piece of paper, right? All right, now, how many edges are perpendicular? It says look at one edge. So let's look at this edge. I'm going to look at this one right here. How many edges are perpendicular to that edge? Remember, what does perpendicular mean? It means straight up and down, right? Straight up and down. Is that perpendicular? Is that perpendicular? Is that perpendicular? Is that perpendicular, right? and then how many are parallel to it? That's what it's asking you. Then B says, look at one face of the cube. Then how many faces are perpendicular to that face? So say you chose this face here. How many faces would be perpendicular to it? All right, that's a little bit harder question. And then how many faces are parallel to it? Well, a parallel one would be right straight across from it back here, right? That'd be parallel. So that would mean perpendicular would be the ones on the sides. All right, go ahead, see what you can come up with. How many edges are perpendicular and how many edges are parallel? And then do the same thing with the faces. All right, so for each edge, there's 4 perpendicular edges. I kind of drew those in for you. That was kind of cheating there, wasn't it? 3, 4. And there's 3 parallel lines. Right, here's one. Here's the original one. Then here's 1, 2, 3 that are parallel. And then the faces, you've got 4 perpendicular ones. So I've got here's my one. I got this one here is perpendicular. This is perpendicular. That one's perpendicular. And that one's perpendicular. The one straight across from it is the only parallel one. So there you go. Hopefully you got the same answer. That was a kind of a tough question. All right, so let's look at this. Workers involved in the manufacturing of packaging materials make boxes and other containers out of flat sheets of cardboard or sheet metal. If we cut apart a cereal box and unfold it, we see 6 rectangles that form the faces of the box. You've probably done this before. Now, if they ask you to find the surface area, if you were to find the area of all of these separate little squares, you add them all together, what you would have is called the surface area, meaning how much area, and you had to cover it all with paper. You know exactly how much paper you needed by calculating the area of all the individual ones. Okay, so let's see if we can do that. Before we do that, let's just visually look at it and do which one of these patterns will not form a cube. So if we fold all these up, kind of look them in your mind, make the fold at each of these dotted lines, make a fold, see which one wouldn't make a box. Can you tell which one wouldn't? I'll give you a second. It's D. D will not fold into a cube. Okay, so now let's practice it. Okay, so if each edge of this cube was 5 centimeters, what's the surface area? Let's calculate the surface area of this cube. Go ahead and do it, and then I'll show you how. Okay, so first thing I'm going to do is I know that because it's a square, that all my sides are 5, right? How many sides does a cube have? It has 6. So if I figure the area for 1 and then times it by 6, I will have my area. So what's 5 times 5? So I know that face right here, the area of this face right here is 25. I know that that right there is also how much? 25. How much is that right there? That's also 25. Then I got 3 more of those. I got 6 of them total. So this is 25. So I take 6 by 25. I get my answer. Then I'm going to square it, centimeters squared, and that's going to be my answer. Now I know 4 times 25 is 100. It leaves 2 more. It's 50. So this is going to be 150 centimeters squared. There you go. That's surface area. That's how you calculate surface area. If it asks you for surface area, you got to figure out all the faces. You got even the one down here on the bottom you can't see. You got to remember it's there. And it's not just the faces you can see. It's the whole surface area. All right. So let's practice what we've done. Give me the geometric solids. Describe each shape. So what's a tent? What's that called? What are these called? That's right. They're triangle prisms. And what is this called? It's upside down. It's a funnel. But what shape is it? That's a cone. And then what is this? You know what that is. That's a rectangular prism. All right. There you go. There's your problems. Send them in to me. And we'll go over these tomorrow. Bring your questions. Thanks for watching the video. Have a good night.